My name is Matt Brown, as you can see there, Vice President in the Management Consulting part of AFRY, and I've been working in the energy transition for about 30 years as a consultant, all the way through, around about 30 years. So I'll hand over to Steffen. Maybe you could introduce yourself.
Good morning, everyone. I'm Head of Future Cities and Mobility at AFRY Management Consulting. We are a practice focusing on the decarbonization of transport systems. I have a background in software engineering and started my first projects on electric mobility 15 years ago, working with German car companies and charge point operators. And today, most of our work is in charging infrastructure for electric vehicles on roads, for cars and trucks. But I love being on water and on all kinds of vessels. I have also been in container terminals for projects with the world's largest container line, and also on straddle carriers. If you don't know what that is, you're going to learn that in this webinar. Over to you, Helle.
Thank you, Steffen. My name is Helle Grønli, and I'm a senior principal located in Trondheim, Norway. And I have a business, an MBA as a training, and has worked in the energy sector also for around 30 years. In maritime sector, I've been working on pricing and business models for onshore power supply, which I also touched on in my previous job, working for Enova, which is a state-owned company providing subsidies for onshore power supply. Back to you, Steffen.
In today's webinar, we're going to start with a short intro and then talk about regulations in maritime sector. We touch on electric vessels and go through a few examples. We are going to cover onshore power supply and then talk about a few opportunities, use cases for electrification in ports. Shipping accounts for 3% of total global CO2 emissions, or 12% of all emissions from transport. And these emissions could increase by 130% by 2050, relatively to 2008, if no actions are taken. And that is why a lot of companies and investors have been working on this. And when we break down and we look at, okay, where are the major emitters, most significant, because they are large in number, are container vessels. There are around 6,000 of them in the globe. And they, just the sheer size, the sheer number of them makes them responsible for 1/3 of all emissions. Oil tankers require much more energy than a container vessel because especially the heavy bunker fuels need to be shipped at high temperatures of 70 to 100 degrees. And also cruise ships need a lot of energy because they need to power the hotel for thousands of people, have roller coasters and so forth. But so there are different cases for the various vessel types, and we're going to go through some examples on how they can be decarbonized. Basically speaking, there are 4 ways how emissions from maritime can be reduced. The first one is just to simply slow down trade, which happens partially, involuntarily, through putting up tariffs, or also literally by slowing down the speeds at which the ships sail on the seas. The second option is that we capture emissions from the engines. And that is a technology, that is something that we are also working on, by the way, at AFRY. It's a technology that's not market ready, but it's what's also going to be, what's currently being developed and what we might see in the future as well. The third option is to use alternative fuels like methanol, ammonia, bio-LNG, and presumably there will be in the future also nuclear through small modular reactors or SMRs. We are working on this as well. And by the way, for the alternative fuels, all of these alternatives, we are going to have a separate webinar in September. So watch this space if you want to learn more of those. The scope of today's webinar is electrification, the fourth way to reduce carbon emissions. And we are going to start with the regulations that are on the bottom of all these movements, of all these developments.
Regulations are a driving force to decarbonize maritime transportation and to establish sustainable business cases for ports and the shipping lines. Regulations need to cover the whole value chain, the whole maritime value chain. Ports or service organizations operating at the ports, they need a market with a critical level of demand. And that's where regulations come in. Shipping lines need guarantees that infrastructure is available at a critical number of ports to make their technology choices. And what this picture shows is key global and European regulations covering the whole maritime value chain for alternative fuels. The value chain covers emissions related to onshore packing and loading, as well as energy supply at the port, and also emissions related to transportation of freight and passengers by sea, and also while berthing at the port. And next, I will go through the key regulations. EU has launched a set of regulations to ensure the availability of infrastructure for alternative fuels at key European ports. And in that way, also establishing a security for technology choices for the shipping lines. And I would like to start with a more general regulation that's not like related to the decarbonizing issues, but it is a key regulation still, and that's regulations 2017-352. That's the general port regulations, not specific for decarbonization, but it sets the general business rules for ports and is also of importance for alternative fuel business models. And these regulations, they're there to avoid monopoly power of port services and also require financial transparency and autonomy. Another key element is that it opens for third-party providers of port services, such as to deliver alternative fuels and power supply services. The next 10T, the Trans-European Transport Network, is a policy for planning and developing a coherent, efficient, multimodal, and high-quality transport infrastructure across EU, and that is at sea, at land, and in the air. And this is also important for the next regulation, AFIR, the Alternative Fuel Infrastructure Regulation, as it builds on the 10T ports and defines which ports need to meet the targets set in AFIR and the technology specifications set in AFIR. And specifically, by the end of 2029, ports need to establish onshore power supply to container and passenger ships exceeding 5,000 gross ton and a given number of annual port calls. So set specific targets on infrastructure. Next slide, please. For the shipping lines, there's also regulations, and that is to secure a market for for the port to offer alternative fuels. And here we have also added IMO, the International Maritime Organization, and a specialized UN agency, which is a key player setting ambitious targets for the shipping industry globally. And IMO is aiming to cut emissions by at least 20% by 2030, on the way to reach net zero by around 2050. And the IMO net zero framework, which was approved in April 2025, combines a new fuel standard for ships called the greenhouse gas fuel intensity, and then combine that with global pricing mechanisms for emissions. And this global framework is planned to enter into force in 2027. And then going back to Europe, Fuel EU Maritime is a part of Europe's Fit for 55 package. And Fuel EU Maritime sets greenhouse gas reduction targets, which is increasing to 80% by 2050. And it also requires all container and passenger ships to use 2% renewable fuels by 2030, and also connect to onshore power supply at large 10T ports from 2030. Another mechanism is the EU ETS, which is EU's general emission cap and trade system. And this system was expanded to include maritime sector from 2025, and will gradually include more of the sector until 2026. And the cap on EU emission allowances is reduced annually by 4.3% per year. For EU ETS related to maritime sector, we expect that the demand for EU emission allowances will exceed the supply through 2050. Just a small insight there. Over to you, Steffen.
Let's look at how these regulations can be achieved, how they can be implemented, and the big important point is, of course, to decarbonize the vessels, decarbonize vessel operations. And so that is the key way to use either fully electric or partially electric vessels. And that market is projected to grow by 17% between 2025 and 2032. So what it means partially and fully electric is very similar to how we see it in cars, where we have fully electric cars or hybrid cars. And one way to obtain quick results, even with existing vessels, is to retrofit them, build batteries on them, electric propulsion, so they can navigate and maneuver in sensitive areas, for example, in ports, in fjords, in protected areas, they can go electric, while in other places they use, for example, the combustion engine running on marine diesel, on LNG, on bunker fuels, and but at least they're temporarily, partially electric. You see there this market growth on the left, which is estimated to grow from this year of a $5 billion market to a $15 billion market in 2032. And there on the right, you see how which type of vessel is most likely, most strongly being electrified in the next few years. And on top of all of them is our car and passenger ferries. The reason is for this that they are on they are on a schedule. It's a designated route they are driving. They're not going anywhere else. And then it is relatively straightforward. And we need to be careful with this. We are going to talk about the limitations in a moment, but it is more straightforward to provide then electricity charging infrastructure to these specific places. But yeah, so let's go into some examples. And here you see a variety of vessel types that are now in this page all fully electric. Just to give you a feeling for where does the technology stand, how far ahead are we, or what's possible today and what's under development. And in general, one can say that the development has strongly advanced in the past years, and also driven from success in road transport and some of the battery technology, and so can even be used, and some of the charging infrastructure can even be used for maritime sector. And these vessel types that exist today support a very diverse set of needs or use cases, as we say, including passenger and car transport, crew transport, tugging, even container shipping, bulk shipping, and these things. So it's a variety of use cases that can be electrified. And there you see the range and the capacity of these ferries. So everything between 30 kilometers and even now a couple of 100 kilometers is possible. And the most advanced ferry that you see there, it's the second from the right. That is a ferry that has just been released recently from a shipyard in Australia, in Tasmania, and it's going to operate in South America between Buenos Aires and Montevideo on a stretch of 200 kilometers or 100 nautical miles. It has a 400 megawatt hour battery that weighs 250 tons. And what you see here is how the batteries, the size of the battery is increasing, or what is possible. Everything between 200 kilowatt battery and even 100 megawatt battery is what's currently available or being developed. To go a little bit deeper in some examples, the most important ferry types I spoke about, the ferries. So one is the RoPax ferry. This is an example from Norway, Europe's largest, or globally even the largest ferry that is operating south of Oslo, and it operates on a 10-kilometer crossing, does that in 30 minutes. Annually, it transports 3.8 million passengers and 1.8 million vehicles, and that has a capacity of 600 passengers in one ride. But the battery, let's look at the battery, because we're energy people. 4.3 megawatt hour battery system and a 9 megawatt charging infrastructure. So this is very serious equipment, and of course also very different from what we see with the cars. And why should these kind of ferries be well? Why will they be used? Why will they be popular? It's out of a number of reasons. They're of course completely silent, locally emission-free, but they're also more easy to maneuver. And here it comes. What's really important for the operators of this ferry is that they also have lower operations and maintenance cost compared to diesel ferries. and especially a big saving on fuels. Of course, they need the adequate power grid connection, the charging infrastructure, and so on. But it's something where it's easy, where it's well, I wouldn't say easy, but where it's possible to build a good business case. Other example, tugboats, they're the ones that move the large container vessels, for example, around in a port, bring them to the right spot. And there are around 50,000 of them in the world, and they also the current diesel-powered version emits a lot of CO2 and other pollutants, and they have been piloted in, for example, in New Zealand, in the Middle East, and quite a few are currently under construction. Battery is at 2.8 megawatt hours, and yeah, that can pull up to 70 tons, and so very powerful. And here as well, so beside the zero emissions in the ports and the noise reduction or no noise, they have also significant advantages regarding the fuel, 30% to 40% less fuel, so fuel cost for the electricity, and then also operational advantages because because of the high automation that these boats have. Fewer crew is needed, a smaller crew to operate. Last example, one of my favorites, I used ferries on public transport a lot in my previous life when I lived in Auckland, New Zealand, but not this kind. So this is a perfect ferry for as a public transport ferry. It seats 15 to 30 passengers, depending on the version. It has 336 kilowatt-hour batteries and a cruising speed of 25 knots. And it has a remarkable technology. You will notice it's called hydrofoiling. So the fact that the ferry looks like it's flying across the water, in a sense it is. And it comes from these struts that you see there at the bottom, and the electric motors underneath it, and that makes them much more energy efficient than the normal displacement ferries. So they are 80 to 90% more energy efficient, and also very maneuverable. Very important also, they are not creating a large wake, and the wake is where the wake building is quite often the reason why there are speed limitations in ports and harbors. And so this is where this new technology can really cut travel time and provide more convenience to users. It's also more stable on the water than a displacement ferry would be. So that is really something that's very attractive. Several companies are working on this. For example, Candela in Sweden, Westwave in New Zealand, Artemis in Ireland. So there are going to be, we are going to see them around there. One is operational in Stockholm, and more are currently being deployed to the Middle East and India and other places. Quickly, what are the opportunities and challenges of vessel electrification overall? So you've seen now a few examples, and all of them have some common denominators. They have zero emissions where that is needed. So it could be for the hybrid ferries also partially only, but then we have no zero emissions locally at that place. The energy efficiency is higher than for combustion engine, lower operating cost, and in many regions and countries, they're also subsidies and market incentives to bring them into operations. Challenges are also worth talking about, and I hinted at it before. The battery capacity, the battery range is limited. And the batteries are heavy, so that makes them unsuitable for long-haul ocean shipping at this moment. So we would need to go really on long-haul, a completely different battery technology that's also under development, but from our perspective, at least 10 years away or more. There are high investments required. For example, so it's not only the ferry, it's the charging infrastructure, it's the power grid at ports, the energy supply needs to be thought through. So how can we really get the renewable energy to the place where the vessel gets charged or supplied with onshore? Yeah. And so that is really another point that needs to be solved. And there are different safety challenges, regulatory challenges, so and requiring crew training, and but I think that they could be overcome. They're the more minor ones. Let's talk about onshore power supply.
Next slide, please. Thanks, Steffen.
Yeah.
So in addition to energy use during transportation, vessels also use a considerable amount of energy while at berth to keep, for instance, hotel operations going for cruise ships. And onshore power supply enables passenger and container ships to connect to the local power grid while they're at berth, and giving the opportunity to significantly reduce air pollution in densely populated port areas. And a study in 2023 estimated this amount to around 6 terawatt-hours for large European ports. And we've tried to show in the map to the right here where the largest at-berth energy demand is located. And as we can see, Italy, Spain, and France, they have the highest amount of energy while at berth. But you could also see like the lighter blue and then lighter and lighter where you have high energy demand when ships are berthing. And it's particularly like passenger, cruise, tanker, and cargo ships that are responsible for around 80% of the total at-berth energy demand. Next slide, please. Onshore power supply, or OPS, has developed in Europe over some time. It started with smaller vessels with recurring port calls. And example of this is ferries, starting around 2010. And then international shipping requires higher degree of standardization and typically larger installations, and came a bit later. And the first European OPS installation for cruise ships was introduced in Kristiansand in Norway in 2018. And that requires more advanced systems. Now, a network of OPS installations for passenger and container ships is developing in Europe, as this map shows. It shows OPS systems in operation and OPS systems being planned at key ports in Europe. And you can see that there's number of dots are increasing, and around more than 50% of these are in operation. And regarding profitability and then pricing related to these installations, there are key factors influencing that is the capital investment, and a factor here would be available subsidies, but also avoiding installing overcapacity. Another key element would be system utilization, increasing the volume or use of the system for instance, through multi-use across different vessel segments. And then energy management, optimizing operations towards electricity supply and markets. And then business model, which I will address a bit later. Next slide, please. But first, to just illustrate what a modern onshore power supply might look like. And a modern power supply integrates smart grid functions and flexible connection management systems. And looking at these pieces, you typically have the connection to the power grid, supplying electricity from national or the national grid or local production. Then you have the smart grid components, managing energy flows and integrating renewable power sources. You need to convert from high voltage to voltage levels suited for maritime use. And what has developed quite a lot the last years is the cable management system, which now is more automated and flexible than before, and that allows for taking tidal waves and various ship solutions into consideration. And then you have the ship interface, to which the cable is connected through a connector. And then, of course, you have more the safety systems supporting all of this, and you have the remote monitoring and artificial diagnostics that kind of support all of these components. Next slide. Thank you. And while the technology is there, still improving, but it's there. Regarding business model, we find a variety of different business models for onshore power supply. And one consequence of that is that it's hard to compare prices across ports. And that might be particularly challenging for international shipping. And the most important difference in business model between European ports is how OPS CapEx is treated. Whether it is remunerated by onshore power users only and then paid for through the OPS price, or if the investment cost is shared by all vessels visiting the port through the general port fees. And another key difference is how power prices are handled, who is facing the volatility of the electricity prices. And some ports offer a fixed price. That means that the port is facing the volatility of the electricity market. Other ports are choosing to pass the electricity price through, meaning that the shipping lines are exposed to the volatility of the electricity market. And as this figure shows, variations between countries can be quite a bit. This compares Germany, the UK, and Norway from 2024, illustrating that electricity prices in the market, they vary over the year, but also between countries. And for instance, if you look at the average price here, the average price for 2024 for Germany and the UK was around 80 euro per megawatt hour, while it was 40 euro per megawatt hour for the Norwegian example here. And this is a sign, or the prices vary, that's natural, but it's the big variety of business model is also a sign that the market is still immature and need to develop. Over to you, Steffen.
Let's look at some electrification opportunities in ports, because in a way, the ports are a bit similar to airports. Aviation can also not be easily decarbonized. There's going to be fossil and sustainable fuels, and but it's not also the introduction of sustainable fuels. It's coming with a delay, and so it's what ports and airports are focusing on is can we decarbonize locally in the ports, not so that is the means for the whole industry. And of course in ports one important element is the container terminal, and this here on what you see on this picture on the right, this is this red beast. That's a straddle carrier that picks up containers from the shunting yard and moves it to the pier where it's get loaded, where the container then get loaded by the crane on the vessel. And of these kind of container handling equipment devices, so there are others like reach stackers, forklifts, and so, and they emit locally a lot of CO2 and other pollutants, and they can be electrified, or there are also hydrogen versions of this, and that is where we see innovative ports now starting to introduce that. For example, we see that in DP World, London Gateway, in Rotterdam, in Los Angeles, in Auckland, Hamburg, and so that is certainly something where the ports have started now to basically to improve or to change their operations. And the same actually on the just stay with the analogy. So in airports, that is electrification of the ground handling equipment, so the pushback tractors, and so they are going to they currently undergo an electrification movement as well. And so here with the straddle carriers, when one of them emits 80 to 100 tons CO2 per year, replacing 50 of them can save CO2 to also that is equivalent to a journey of a large container vessel from Hamburg to Singapore. Container buildings, terminal buildings can also be decarbonized by, for example, using solar PV and integration in local grid, in community grids. And then last point, leisure boats are also being electrified, and there are charging networks similar to what we see from cars, charging networks evolving in the Mediterranean, but also in the UK and Sweden. Okay, sorry that I then was looking at the wrong schedule, but here's the last page. We are, so let's draw some conclusions. There are many different solutions for decarbonizing maritime transport at sea and at port, and that some market regulations still need to be brought in place, also on the onshore power supply, to set business models and targets that bring the various players in sync, notably ports and shipping lines, but there's a complex relationship, and for example I mean many ports and many shipping lines, and they all need to align. So that is a challenge. Electric vessels are emerging. You saw some examples. The batteries are growing ever larger, and then you can see also there's also potential to manage that energy smartly in some places at least. And the industry is still at an early stage, we have to say, but there are products on the market and solutions that work, and so you need to look for those, for the routes, for the vessels that make sense and can create a positive business case in certain areas. There's a strong interdependency between shipping lines, ports, the energy producers, different ones than in the past, the power grid and the charge point operators. And overall, we can say the electrification of maritime sector can be financially and environmentally rewarding. That's what we are convinced of. Okay, so then, well, last point here. Please reach out to us if you want more information, and join us for the next webinar when we talk about alternative fuels in September. With this, I want to see if we have we have a little bit of time for questions, maybe one or two.
Yeah, I think we can take one or two questions just quickly, and obviously some people might need to drop off along the way. But so we've got a few. We had a few up front. Maybe I'll just pick one or two here. Steffen, on the primary barriers to scaling electrification in short and medium distance maritime transport, how can investors help overcome these barriers?
Okay, so I would really differentiate between so short distance transport, depending on what distance you're really looking for. That is possible in many ways with some of the small ferries and vessels that I showed, the work boats, and so products are basically there. There it's about capital for vessels, so for to implement projects for the infrastructure as well, for the grid connection, and so that is really then investing into bringing it all together, the various components. For medium distance maritime, it requires more thought, more maybe investments into new battery technology and other chargers than that are on the market today, and so that is more than a development question, product development or component development that needs to happen there.
Okay, thanks for that. And one for you, Helle. Given sort of onshore power systems, the installation for onshore power, some of these things are pretty big. Is it always easy? Do the ports have the space? Is it possible to get, more cables, more infrastructure down to these ports that could be there?
So of course, space might be an issue at many ports, and so may also getting access to electric grid capacity. And we think this will evolve over time. So now it's starting to building out a few connectors and then increasing to many, similar to what happened with EV charging infrastructure on roads. But of course, this also requires cooperation between local governments who kind of regulates the land of the municipality. It requires cooperation with the port authorities, the electric grid companies, energy providers, and shipping lines.
Yeah, so a lot of coordination needed. And as ever, across the power sector, from a power sector perspective anyway, the connection is a topic which is right up there for everyone, super important as we decide actually how we're going to electrify, especially as the rise of data centers taking connection priority as well in certain places. The next webinar on alternative fuels in maritime decarbonisation, Steffen, how far away is that? Is that a week away?
It's planned for September. Edwin knows the date. I think
September.
It's already set.
Okay.
Yeah, it's 25th of September we're targeting.
25th of September. Lovely. So if you want to learn about the other option or one of the other options for decarbonising maritime, then of course alternative fuels would be a very important part as well as electrification. Please come back for that one. So thank you to everyone. Thanks Steffen and Helle and Edwin, and thanks everyone for joining and listening to the webinar, and we hope to catch you soon. Cheers.